This week we will talk about alternating current. Okay, so till now we have subjected resistor, capacitor, inductor, these devices to a constant voltage source. And this week we are going to see what happens when these devices are connected to an alternating source, how they respond. Okay, so alternating current circuit is our main agenda this week, right? So how to simplify circuit, how to analyze the circuit, all these things we are going to discuss. So before getting into the response of different devices to alternating source, we will first talk about what is alternating current and what are the important parameter we keep using, right? So some standard terms will be there that we will keep using. So we will first define those terms so that in subsequent classes you won't be having any problem related to the definition of the basic terms. So what is alternating current? Let's start. So by definition, a current which changes its direction comes under category of alternating current. While direct current will have the fixed direction, it is not changing its direction. Alternating current changes direction periodically. It also changes the magnitude periodically, right? So magnitude and direction both are changing periodically, while for direct current there is no change in the direction. Okay, so if I talk about the variation, look at these graphs. So first one, the constant DC. So if I have one resistor, I connect it to a voltage source. This is the variation what I am going to get, right? So current will be constant and it is called constant DC. Similarly, you can see here, second graph, current changes periodically, but it never goes to negative territory, right? Current is always positive. That means current keeps flowing only in one direction. So this is called periodic DC. Similarly, look at third one. If I connect resistor to inductor, for this situation we got variation as I is equal to I naught 1 minus e to the power minus RT by L, right? This variation, if I plot, this variation will be something like this. So current is increasing in magnitude but it is not changing in direction. It is always in positive territory, right? And if I have an inductor which carries some current and it is connected to some resistor, then we have seen that the variation of current as a function of time was something like this. Look at this third curve. So current is decreasing with time, okay, but it never goes to negative side, so direction is not changing. While if you look at fourth graph and fifth graph, see, we have current flowing in one direction, then current changes its direction and starts flowing in opposite direction. So for some time current will go like this, and then current will flow like this. Let's keep changing its magnitude and direction. This is called alternating current. Okay, AC, alternating current. We may have a situation where magnitude is fixed. Look at fifth graph. So magnitude is fixed, but the direction is changing. This also comes in the category of alternating current. So because we have plus I and we have minus I, so current whenever changes direction, it is called alternating current. If current's direction remains same, it is called direct current. So I hope basic definition of direct current and alternating current is clear, right? Now we'll define some terms which we'll be frequently using for upcoming subtopics. Let's see that. Average value. So average value of any function, say y is equal to ft. I want to find out the average value of this function. The formula for average value is y dt integration from t1 to t2. I want to find the average value of the function. So in place of y, I can write the function, and I'll integrate the function for this given interval t1 and t2. So this will give me average value of the function. Here you can see this way also I write the average. Okay, so meaning of these brackets is we want to find out the average value, and here in denominator we are writing interval. So if you integrate this term, you are going to get interval. So integrate the function and divide by its interval will give you average value. So if we have y and this is time, and say this is the variation, so y dt will give you the area of this strip, and if I want to integrate from t1 to t2, that means I am calculating this area. So another way I can write the average value. Look at the term we are getting here. This term. This is nothing but area under ft curve. So in numerator I can write area under ft curve divided by time interval. Look at this one. This is time interval. So area under ft curve divided by time interval will also give you average value of the function. So if curve is given, we will get the area, and divide by interval, we will get the average value of the function. So I hope the definition of average value is clear. Now let's see one situation. So I have taken a sinusoidal function. This is called sinusoidal function. We may have sine function, we may have cos function over here. Similarly, there might be some phase constant, omega t plus phi. Okay, so we may have function like this. So let's first take a simplest function, that is I is equal to Im sine omega t, where Im is called peak value of current, a peak current. So this is peak value. Okay, and if I ask what is the average value over one time period, over one cycle. One cycle means 0 to capital T. Okay, what is the average value of current over one cycle? So formula is integration I as a function of time, I'll write here dt and then dt integration. Okay, as I'm calculating for one cycle, look at this one. This graph actually goes up to infinity. This variation is going up to infinity. I want to find out average value over one time period. So you can see that this part of graph is repeating itself. Okay, so from here onwards the graph will be same. So this is called time period, and this is half of the time period. So over one cycle means from this point to this point I want to integrate. Let's substitute the function. Function is Im sin omega t dt 0 to capital T and then dt 0 to capital T. If you look at denominator, integration of dt will be t and upper limit minus lower limit, this term will come t. So t I am writing in denominator, Im as it is constant, it will come out, and then integration of sin omega t. Integration of sin omega t will be minus cos omega t, right? So minus cos omega t 0 to t, and omega will come in denominator. Okay, so this way I write Im t omega. Here I can write lower limit minus upper limit, so cos 0 minus cos omega into t. See, t is 2 pi by omega, where omega is angular frequency. And t is time period. Right? Cos 0 is 1 and cos omega t is also 1. So this whole value is coming 0. So average value of this function over one cycle is coming 0. If I go by area between curve and time axis, I can see that here area is positive and here area is negative. So by seeing area itself, I can directly say positive and negative, if you add, this will become 0. So that's why this value is 0, because for average this numerator is what? Area under curve. So as area is coming 0, directly I can say this value is 0, right? Now if I want the average value for half of the cycle, that means I want average value up to t by 2. So same way I'll write and I'll just change the limit. Look at this one. This is t by 2. So t is equal to 2 pi by omega. T by 2 is nothing but pi by omega. So I can write t by 2 as pi by omega. So that's what I have written here. and we are integrating from 0 to pi omega. So if you integrate this one, then integration of sine will be minus cos, lower limit minus upper limit, you are going to get this. Here omega will get cancelled out, and you can see cos pi is minus 1, this minus and this minus will give you plus, omega getting cancelled out, and we are getting 2im by pi is the average value of current. So I can say average value is 2 by pi times the peak value. Average value is 2 by pi times the peak value. Provided our function is sinusoidal. So if variation is sinusoidal, then for half cycle we are getting this expression, and for a complete cycle we are getting this expression. So I hope both are clear, first one and second one. Now let's locate this one on the graph. So for this half cycle, if I want, then this is the peak value, right? Im. And if you look at this one, 2 divided by 3.14, if I write, then this value is less than 1. That means the average will be somewhere here. This is indicating 2 by pi times Im. So if you take half of the cycle, average value is non-zero because all the values are positive. You can see these all values are positive. You are getting average value, this one. But once you add one more cycle, if you add this cycle, the positive value and the negative value, they will cancel each other and you are going to get 0. I hope this discussion is clear. Let's see some example based on this one. Look at this one. So this equation is in format Im sine omega t plus phi. Okay, and comparing these two equations, you will get omega as pi. If omega is pi, then t is equal to 2 pi by omega. And if I place pi over here, then we are getting time period as 2 seconds. And the interval for which we need to find out average value is half of that. Okay, and just now we have seen that if I is equal to Im sine omega t, for half of the interval the average value of function comes 2I max divided by pi. But the problem here is this pi by 4, right? So as we have this one, the graph will be, instead of starting from here going like this, graph will be something like this. So now you can see you cannot use this formula because the expression is not same. It is not Im sine omega t. It is Im sine omega t plus phi. So additional term phi is coming. So because of that, I cannot use this one. So how to find out the average value? Again, we will go to the basics. We will apply the formula. Formula for average value. I average is equal to current as a function of time that are integrated with respect to time. So current as a function of time 2 root 2 sine pi t plus pi by 4. Okay, and then here 0 to 2 second, 0 to 2 second. So in denominator you can see that integration of this one will be t, and upper limit minus lower limit 2 will come. This 2 and 2 will get cancelled out, root 2, and sine integration is cos pi t plus pi by 4, 0 to 2, and this pi will come in denominator. So if I write cos upper limit cos 2 pi plus pi by 4 minus lower limit, if I write 0 to 1 second we need to find out. So here I'll add 1 second. Okay, look at this one. So this is 1, not 2. So upper limit is 1. So when I write 1 second here, I'll get pi only. Cos lower limit t is equal to 0. So here you write 0, you will get pi by 4. Cos 180 plus pi by 4. So this will give me 2 times pi by 4, right? One by root 2. And here this is 1 second. Okay, so 1 2 I can see here. So 2 root 2 by pi, and then 2 times cos 45 root 2. This 2 and 2 will get cancelled out. We are getting 4 by pi. Okay, so this answer is different to what we derived for Im sine omega t. That was 2 Im by pi, and you can see that Im is, if I substitute 2 root 2 into 2 divided by pi, we are getting 4 root 2 by pi, which is wrong. So do remember that whatever you are writing directly, for which situation it is derived. Okay, so as this formula is derived for this situation, it can be used for this situation only. Here we have additional term, that is pi by 4. So we are again solving it completely to get the value of average current, right? Now same way I can have a different function. Instead of sinusoidal function, I may have some triangular waveform. So this is triangular waveform, and for this, if I ask what is the average value of current from 0 to 2 seconds, just now I told that current average is area under IT curve divided by time interval. Area here I can easily calculate. Triangle, half base into height, half base is 2, height is, this is 10, divide by time interval is 2, so this and this will cancel out, we are getting 5 ampere. So average value of current for this situation, we are getting 5 ampere. That means for this part, on average value is coming here like this 5 ampere. If I take average for 0 to, this will be 4 second, right? 0 to 4 second, as whatever positive area we are getting, same negative area will come for this part. So these positive negative will cancel each other, and we are getting average as 0. I hope procedure is clear. So definition of average is clear. Now we will define one more term which is called RMS. Okay, root mean square. Let's see that RMS. So if y is written as function of time this way, अब this y can be current, y can be voltage, it can be power, it can be anything, right? First what we do, we get the mean of square. Mean of square once we have mean of square, we put under root over it, and it is called root mean square. Okay, so y RMS, it is represented by RMS, root mean square. So here I can write under root ft square dt integrate dt for given interval 0 to t or t1 to t2, right? So if I want to generalize the expression, then from t1 to t2 I'll integrate, I'll write interval here, this is t1 and this is t2. Okay, so I hope formula is clear how to get the RMS value. This way also I can write, I'm just writing interval in denominator and then integration of f square in numerator. Okay, what is the use of this value, what is the use of average value, later we will see, but right now our focus is just defining term, what is average, what is RMS, and how these terms are calculated. Okay, so let's see one example. So I have taken a sinusoidal function and I want to find out average value IRMS for 0 to say t by 2, that means for half cycle. Okay, so for half cycle what would be the value of RMS? that we need to find out. So according to formula, I am sine omega t whole square dt integration 0 to t by 2, right? 0 to t by 2. This will give me RMS. So denominator t by 2, and then this is IRMS square. So I'll take this one, or I can also write Im square divided by t by 2. So separately I have written this term. Now sine square omega t can be written 1 minus cos 2 omega t by 2, right? So if I substitute this value here separately, let's calculate the value. So I need integration of sine square omega t from 0 to t by 2. dt. So here this will become dt by 2. Dt I multiply inside, and then cos 2 omega t by 2 dt. Zero to t by 2 and 0 to t by 2. Integration of cos will give you sine 2 omega t divided by 2 omega 0 to t by 2. If I integrate this term here, this I am getting t by 2, and then one more 2 is there. So this is the function we are getting. And sine, if you look at the sine, then this is coming sine 2 omega t by 2 minus sine 0 omega t is equal to 2 pi by omega, right? That means t omega will be 2 pi. Here if I write 2 pi, sine 2 pi is 0 and sine 0 is 0. So this whole term is coming 0. This whole term is 0. That means we are getting t by 4. So integration of this one is giving me t by 4. T is getting cancelled out, and we are getting Im divided by root 2. Okay, here 2. So this is IRMS for half of the interval, right? Now if I ask what is the RMS value for full interval, so now I want for full cycle. Okay, so this is extended and this is going up to infinity. Now for full cycle, for one complete cycle, what is RMS value? So IRMS for zero to capital T. That means for a complete cycle. So same way I can write, right? Now this time is what? T is 2 pi by omega. Sine square. Just now I wrote 1 minus cos 2 omega t by 2. dt will give me sine square omega t dt. Okay, this integration I need. So first term will come this one, and second term, if you look at cos 2 omega t by 2, when you are integrating with time, then you are going to get sine 2 omega t. 0 to capital T you are integrating, 0 to capital T. So first term will give you t by 2, while the second term 0 to capital T if you do, then look at this one, sine 2 omega capital T minus sine 0. So this is 2 pi, as this is 2 pi, 4 pi, sine 4 pi is 0. This whole term, this is 0 and this term is 0. This whole term which is coming here, that is 0. That means only t by 2 you are getting after integration, right? So after simplification we get this one, and then Im by root 2. So no matter whether I take half cycle or full cycle, we are going to get Im by root 2. So for full cycle also I am getting RMS value Im by root 2. I hope this part is clear. This part is clear. So look at what is happening. If you are squaring this term, then this part of the graph is coming up. So graph will be something like this after squaring. So whether you take half cycle, or you take both the cycles, both half cycles, the average value will remain same. So for one half cycle, whatever average value you are getting, for this two cycles, two half cycle, the average value will remain same. So RMS value will remain same, but average positive, because of positive and negative, it is coming 0. But as for root mean square, you have to square the function, whatever coming in downward or at the negative side, that after squaring will go up. I hope you understood this point. So these are the two important values that we need to remember for any sinusoidal function, which is written in this form, Im sin omega t. One is the average value that we just got, 2 Im by pi, and another is RMS value. RMS value is coming Im by root 2. So peak value times 1 by root 2 is RMS, and average is 2 by pi times the peak value. So keep these 2 points in mind. Now let's see one example. So I have taken the same function just to make you understand. So triangular waveform I have taken, and I am asking what is the RMS value. Question is find the RMS value. Find IRMS. Okay. For 0 to 2 seconds. So as you can see that there are two different functions. One is this one. So 0 to 1 second, I am getting current as 10 t y is equal to mx, right? And then from 1 second to 2 second, we are getting y is equal to mx, right? So I is equal to minus 10 t plus y-intercept. Y-intercept I can calculate by substituting this point. So if I substitute I is equal to 0 at t is equal to 2 seconds, then c I can see plus 20. So the equation I am getting here is plus 20, right? So for different time interval, function itself is different. If I write the formula, under root 0 to t ft dt square 0 to t dt. So here, as the function is different for different interval, what I'll do, I'll break the interval 0 to 1 second. We have got 10t function whole square dt, and then 1 second to 2 second, it is minus 10t plus 20 whole square, right? And then in denominator you need to write interval. Interval is 2 seconds, right? Now it is little lengthy to solve this one. What I can see in diagram, whatever be the RMS value of this function, same will be RMS value of this function. So when I take the complete interval, I am going to get the same RMS value. So instead of doing all this, I can follow the easier method, like I just calculate the RMS value for this interval, and that will be the RMS value for 0 to 2 second also. So 0 to 1, 10t whole square dt divided by, now interval I reduce to 1 second, here I'll add 1 second, under root. So by this way I can easily get the answer. Okay, so 10 will come out, and t cube by 3 I can see, t square integration t cube by 3, right? Upper limit minus lower limit, so 1 by 3. Okay, so under root 1 by 3. So 10 divided by root 3 ampere. So this is the RMS value for 0 to 1 second. IRMS if I ask, answer is 10 by root 3. 0 to 2 second if I ask, what is the RMS value? Answer is 10 by root 3. 0 to 4 second if I ask, answer directly you can tell, 10 by root 3. But be careful, right? If I take some intermediate time, say for example 1.8 second, so 0 to 1.8 second if I ask, what is the IRMS? I don't know. So I need to write this interval here, I need to change the limit here, and I have to follow the same procedure to get the RMS value. Okay, so any other function given to you or any other interval given to you, this is the procedure, right? So I hope this whole procedure is clear. Now let's see another situation. Effective value, later I'll tell you. Effective value means RMS value, root mean square value of the current. So here you can see we have got one constant term and then one sinusoidal variation. Okay, and question is what is the effective value. So let's do one thing, let's generalize this expression. So instead of using this one, I'll use I is equal to some constant term, peak value, sin or cos omega t, it does not make any difference. Okay, so B sin omega t. Let the function be in this format, a plus b sin omega t format, and I want to find out RMS value of this one. So first step is writing the formula properly. current square dt. One more thing, when nothing is said about the interval, it is for one cycle. Okay, for RMS value it is one cycle, and for average value it is half cycle when nothing is said about interval. So obviously we are calculating it for one cycle, 0 to capital T. Now let's substitute the value. So here I'll write a plus b sine omega t or cos omega t, it can be anything. Okay, let's write cos because in the example cos is written. Cos whole square dt 0 to t if I open this bracket, I'll be getting a square dt b square cos square omega t dt, and then 2 times ab cos omega t dt. So I just open the bracket and look at the denominator dt integration will give you t. Okay, so 1 by t I am writing out. And I'll take all the constant term out. So here I need to integrate dt, here I need to integrate cos square, and here I need to integrate cos omega t. Limit is 0 to t under root. So one by one, let's see all the term. So cos omega t dt is sine omega t by omega 0 to capital T, right? So sine omega t, upper limit minus lower limit I am doing, omega t minus sine 0. Okay, divide by omega. Omega t is 2 pi, so sine 2 pi is 0, sine 0 is 0, this whole value is coming 0. Now let's look at this term, cos square omega t. So cos square omega t, that can be written 1 plus cos 2 omega t by 2 dt. I am substituting the value of cos square omega t. Okay, if we simplify, first term is this one, t by 2, and second term is cos 2 omega t by 2 dt, 0 to t, 0 to t. So first term I am getting t by 2, and then second term, look at this one, cos 2 omega t, integration sine 2 omega t divided by 2 omega into 2, 0 to capital T. So sine 2 omega capital T minus sine 0 divided by 4 omega plus t by 2. Now as this quantity is 2 pi, this whole thing will be 0, this will be 0, and this term will be 0. So we are getting t by 2, we are just getting t by 2. So this integration will give me t by 2, right? Here t by 2 into b square plus, look at this term, this is a square t whole divided by 1 by t. So this t cancel each other, and then a square b square by 2 is left. So this is the RMS value of current. So most of the time you are going to get such type of function. For such type of function you need not to do this procedure again. If you can remember this formula, a square plus b square by 2. Okay, now I substitute the given value in the expression and let's see what we are getting. So if I compare, A we have 2 and B we have 4. So IRMS what we are getting is under root 2 square plus 4 square by 2. So under root 4 plus 16 by 2, and that is under root 12. And this, if I further simplify, I am getting 2 under root 3 ampere. So IRMS is coming 2 under root 3. So I hope this whole thing is clear. Any change what we have learned, any change in the format. See this one. I is equal to Im sin omega t, or it can be I is equal to Im cos omega t. As long as functions are written this way, then so you have IRMS as Im divided by root 2 and I average is 2 Im divided by pi, right? And even if it is sin omega t plus some phi, and question is for half cycle, okay, then you have seen that you cannot apply all these formula, because what matters is from which time to which time the value is to be calculated. For example, if graph is something like this and I start from this point to this point and I ask average value, so average value directly I can write the formula 2 Im by pi. But if I start the time from somewhere here and that time ends here, though it is capital T by 2, so in this situation these values and this value will give you different answer. Then answer won't be like this, right? So procedure, apply formula, and then accordingly get the answer. And just now what we have discussed, if some constant term is added, I is in this form, if some constant term is written, and then we have b sin omega t, a plus b sin omega t. So a sinusoidal variation plus a constant, if it is written this way, then IRMS is given by a square plus b square by 2. b square by 2. So you can see that if a is 0, then you are getting b by root 2. This is the result when a is 0. But when a is non-zero, then formula is a square under root a square plus b square by 2. Okay. Now, I hope all this derivation, everything is clear. So similarly, if I give you another function, if I say it is 4 minus 3 sine 2 pi d, what is the RMS value of current? So RMS, we can directly write this 4 square 16 plus this is 9 divided by 2. Okay, so simplify, this will be 4.5 and this will be 20.5 under root 25.5 ampere would be IRMS current. So today we have seen what happens when a constant term is added into this sinusoidal function. In the next class, we will take both the functions sinusoidal and then we will see how to add them. Okay, how to add and how to find out the IRMS current. So remember this result, and in the next class we will see what happens if we have more than one sinusoidal variation, how to find out the value of IRMS current. And in the next class we also discuss what happens when different devices are exposed to alternating current. Okay, so I hope everything what we have discussed today is clear. You must have enjoyed today's class, right? So thanks very much for watching.